Hi children, today we will talk to you about the triangle inequality. Let's make an entry like this. Teacher asked Bedul, who was staying at home during the quarantine days, to make a triangle with using the objects in the house. Bedul is trying to create a triangle by combining the tips of two black colored pencils above and the tips of one of the different length pencils below. Which of the following items do you think can form a triangle? You see pencils of different colors and lengths. You stop the video and think and try. After a little thinking, Betul started to connect the tips of the pencils, beginning with the green pencil that is 1 centimeter. This is not a triangle uh, because it's not combined, and this is not a triangle. This place looks like a triangle, but that is not exactly what is desired. It is not tip to tip, and that is not. This is not a triangle. And after she tried brown pencil that is 2 centimeters, it is not a triangle. Um, this is looks like a triangle, but it is not exactly what is desired. Um, this this is not a triangle. And after she tried yellow pencil that is 4 centimeters, it's bingo. This is a triangle, and this is tip to tip. And red pencil that is 5 centimeters. This is a triangle. Yes, and after she tried blue pencil that is 8 centimeters, that is not exactly what is desired. They are uh, this is not triangle. They are equal length. Some of black pencils and red pencil, not red pencil, blue pencil. And she tried finally orange pencil that is 11 centimeters. That is not exactly what is desired, and that is not a triangle. Orange pencil is longer than the sum of the other black pencils, and Betül was able to form a triangle with two of these pencils, uh, this and this. Uh, Stop the video and what do you think our inference should be from this data? Yes, there can be many different ideas. Betül is a smart student. She thought a lot of things, but the most logical ones, if we know the length of the two sides of a triangle, the third side must be smaller than the sum of the other two sides, and the third side must be greater than the differences of the other two sides. Uh, let's see if this inference is true using the GeoGebra application. Let's choose the length of black pencils, 5 and 3 centimeters. Length between points A and C is small letter B. B is 5 centimeters and C is 3 centimeters. We choose a side, A side, and we can also choose angle A. Angle A, you see. If we move point B, as the angle increases, the length of the A side also increase, and the angle A gets smaller. The length of the side A and A becomes smaller. And now, approximately 0 degrees, uh, length of side of A 2 centimeters, but when B and B side and C side overlap, and the triangle does not form, and A increases and A side increases, and angle A in this case is about 180 degrees. Points A, B, and C, the dots are linear. AH becomes the sum of B and C. 5 plus 3 equals 8 centimeters. But this shape is not a triangle, but the dots are linear. It requires 3 nonlinear points to be a triangle. We see from this application that Betul is right. The length of each side is less than the sum of the lengths of the other two sides and greater than the difference between these lengths. So A must be greater than 2 and less than 8. So should be between 2 centimeters and 8 centimeters. Let's solve an example for reinforcement. Sample, if 6, 8 and x represent the lengths of the sides of a triangle, how many integer values for x are possible? The figures. And remember that in a triangle, the range of possible lengths of a side depends on the lengths of the other two sides. Stop the video and solve. Yes, Solution. The length of a side must be less than the sum of the other two sides. Here, that means x is less than the sum of 6 to 8, or x is less than 14. And in addition, remember that the length of a side must be greater than the difference of the other two sides. That means x is greater than the difference of 8 and 6, or x is greater than 2. Therefore, we have two limits for the value of x, 2 and 14. X is less than 14 and x is greater than 2. Since x is an integer, x can be equal to numbers 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, or 13. So x can take 11 integer values. You see ABC triangle and length between points B and C, side A, and length between A and C, B side, and length between points A and B, C side. If B is greater than C, A side is greater than the difference of B and C sides and smaller than the sum of these. Or a side is greater than absolute value B minus C because the length is not negative, and a side smaller than the sum of these. The same inequality applies to other sides B and C. We say this inequality the triangle inequality in mathematics. To remind you again, the length of each side is less than the sum of the lengths of the other two sides and greater than the difference between these lengths. Do homework questions and follow the next non-routine problem and solution video to better understand the issue. Have a good day.